Okay, so welcome back everyone. SatRevolution Session O webinar on improving Earth observation services with onboard artificial intelligence. And a quick slide about SatRevolution. So our company was founded in 2016. We've launched our first 2 satellites to orbit in 2019. We're currently working on a number of dedicated and shared missions that will be launched at the end of this year in December 2020. So by then, by the end of this year, we should have 7 satellites in orbit. And our big goal at this stage is the launch of the first stage of our Earth observation constellation called REC, Real-Time Earth Observation Constellation. That should happen in 2023. We're specializing in Earth observation technology, so optical payloads and subsystems that go with them. We have a few shared missions with optical payloads that we're launching next year. So if anyone is interested in joining, you should let us know. With this, I'm passing over to Taufik. So please go ahead.
Hello, everyone, and welcome to our webinar. Obviously, it's very early in Australia at the moment, so a very good good morning to all of you. So SpiralBlue, we're proud to work with SatRevolution on our first launch, and I guess this webinar we'll be looking at what SpiralBlue is doing, and obviously the tagline says uncovering insights from orbit through space edge computing. So I guess space edge, number one, is our onboard processing capability. And I guess the question is, well, what can we do with this? So next slide, please. Yep. So obviously we can see here a satellite image of some farmland. Suppose that you're a farmer in this area. Next slide, please. Yep, and you own some land in this area, and you started to hear that these satellite images are being used to improve productivity, to improve, to reduce costs, and achieve environmental benefits. And so you think, okay, this is something that maybe I should try out. So you look up online, you look at some websites, you call up some people, and you find that satellite imagery costs, at least the high-resolution tasked imagery, costs about $50 per square kilometer, let's say. And you think, perfect, I have about 1 square kilometer of land. That works out to $50 in total. That's not a massive expense, so happy to pay and see what I can get. But of course, next slide, please. Now, you only need this, but with tasked imagery today, you need to buy the whole image. So this is the difference between archive imagery and tasked imagery, that with archive imagery, often you can buy just a small fraction of an image to get exactly what you need. But with tasked imagery, you do need to purchase the whole image. Now the whole image in this case is probably about 100 square kilometers. So multiplying that out, that's a $5,000 total price. So you're paying 100 times more than you need to for an image that you don't need 99% of. So this is the situation with satellite imaging today. So how does this onboard processing capability, space edge computing, how does it change things? Next, please. Yep. So with our space edge computer, what we're capable of doing is cropping the image down to just what is needed. So you don't have to pay for this whole massive image that you don't need 99% of. So in fact, you can see a picture of our first flight model of Space Edge 0 computer that's actually on the way to Poland at the moment to be integrated with the Swift satellite. So hopefully no issues on the poster there. But what's the benefit of this? Next, please. Yep. So in this case, the farmer goes from having to pay $5,000 for this whole image to only having to pay for the part that he needs, which is $50. So it's 100 times cost saving. Pretty simple. And next, please. Obviously, I've spoken about the benefit here in agriculture, but similar benefits can be achieved in other industries as well. So energy, oil and gas, government and planning. financial services, and of course defense with regard to things like maritime surveillance. So many of these industries don't need full images. So for example, with energy, often utilities have just a strip of land that they need to image. They don't need to take this whole image, they need a very narrow strip. So we can do a similar in that area. And in other cases, we're also using our artificial intelligence capabilities to do object detection, as we're doing for defense with a product we're developing called Vessel Detect. So what's the team that's developing Space Edge? Let's have a look at the next slide. Looks like it's a little bit broken, but that's fine. My name is Taufik. I'm the founder and CEO of SpiralBlue. We started SpiralBlue in late 2018 after about a year of market research and development. And my co-founders are Dr. Henry Zong, who is our head of AI. He's an AI scientist, holding a PhD in computer vision, and is an expert in edge computing as well. And of course, third co-founder is James Buttonshaw. He is a former defense and government defense systems engineer, and he is our head of hardware. Now, throughout the life of SpiralBlue, we've been in various programs, and we've also got a few advisors on board as well. Next, please. So having started out in late 2018, we initially found some customer interest and started to develop some of our artificial intelligence capabilities that we intend to run on the Space Edge Zero mission coming up later this year. Next, please. And then about mid last year, we were successful in getting some funding, both from friends and family sources, as well as from the state government here in New South Wales. So very proud to be funded under the Minimum Viable Product Grant. Yeah, I mean, the government has done a lot to support us. Next, please. And in this time as well, we've developed our hardware, and we've also been approaching defense and looking to work with them to produce Vessel Detect and ultimately to provide a platform for Space Edge to be used for defense purposes as well. Next, please. And of course, today, the reason I'm speaking with you is that no earlier than December 2021. No earlier than December 2020, we will be launching Space Edge Zero to space. So I say no earlier than because, as we know, launches can of course be delayed. And so this is a really big step forward for SpiralBlue, as you can guess. A space business is not a space business unless it has sent something to space, in my eye. So we're really excited to learn as much as we can. This has been a very compressed schedule, so we've gone from contract signature, I think, in March or April to launching at the end of this year. So there's certainly a lot that we're going to be learning from this mission. And the reason I wanted to speak with you today, so next, please. So currently we're seeking partners in satellite image distribution and analysis. So what this means is we're looking for organizations that distribute or analyze satellite imagery to explore how they may be able to use this space edge computing capability. We're really keen to understand how can we best serve our customer, simply put. And the approach we're taking with this is because this is very much a test mission where we're looking to learn as much as we can. We're not expecting we can figure out a deal, let's just say. So don't worry too much about the cost. And yeah, that's it for now. If that's something that's of interest, please don't hesitate to get into contact. Next, please. These are my contact details. So yeah, let's make it happen, and let's have a discussion.
Thank you, Taufik, and apologies for a bit of a hiccup on the slide formatting there.
No worries.
Thanks again. So we have a question from Alexander on the call. With what frequency are you capable of delivering new imagery of a given land strip? So I guess I'm going to take that because it's more down to to the satellite and the orbital parameters and parameters of the ground station coverage that we will have. Yeah, so it mainly depends on that. So in the current December 2020 mission, we will have between 2 to 4 ground station sessions per day. So I guess whatever, you know, images that we're able to downlink during those sessions, we will have. Since it's a single satellite, we will also need to take into account that it's not going to pass many times over the single point on Earth because the orbits change. But that's something that we're working on towards having more satellites in orbit and essentially having a constellation there. So I hope that answers your question.
Yes, thank you. But could you at least estimate what is the period of passaging over a given point?
Let's say at this stage it's daily updates.
Okay. Okay. Great. Thank you.
Yes. If we have any more questions from the audience, now is the great time to ask them. If not, let's go to the next slide, and it looks like most of the audience is here for that. So the penultimate prize clue for a little giveaway competition is the word "to" in English. So TWO2.